Hi, good morning. In this session, we will discuss about materialized view. What is materialized view? Why do we use materialized view? What are the advantages of using materialized view? And which real-time scenario we go for materialized views? And what is the difference between view, materialized view and table? These are the basic things we will be covering in this session, along with the materialized view concepts, the types of materialized views, the refresh options, etc. What is a materialized view? Materialized view is a database object. It will be stored in the database. It is different from normal view. The basic difference between normal view and materialized view is view does not contain any data in it, whereas materialized view contains data in it. Means materialized view stores data. Normal view does not store data in it. This is the basic difference between normal view and materialized view. Especially, we create materialized views for remote database objects in our local database. That means we create materialized views in our local database based on the objects that are present in the remote databases. What do you mean by remote database here? A database to which we have not connected is a remote database. The database to which we have connected becomes local database to us. All other databases becomes remote database to our local database now. This remote database can be present in a different time zone, or different region, or different country, different state, different city, or different building, or maybe different room, or maybe different computer in the same room, or the different database which is lying on the same server or same system. In one system, we can have two different databases. Let's take an example. We have Oracle 11G and Oracle 12C databases together installed in the same system. Now we have connected to Oracle 11G database. So 11G database becomes local database to us now. The other database, which is 12C, which is present in the same system, becomes remote database now because we have connected it to 11G database. That means 11G database is remote to 12C, 12C database is remote to 11G. The databases need not be different versions. They can be of the same version. Let us take another example. In the same system, we have installed Oracle 10G as home 1, one more Oracle 10G as home 2. Now we have two different databases in the same system with the same version of Oracle 10G. Now home 1 is remote to home 2, home 2 is remote to home 1. So the remote database need not be present in the different country. It can be present in the same system as well. The database to which we have not connected becomes remote database. The location could be anything. It could be same system or a different room or different building or different city or country. Which we have not connected is the remote. Now we wanted to connect to remote database every time from our local database to bring the latest data. Take an example. We have local server in India and remote server in US. The business is happening in India as well as US. But the Indian business data we are storing in Indian server, which is located in India. The business which is happening in US, we are storing the data in the server which is present in US. So both servers are having different data now. Now we need to do a consolidation of both data from both the servers and generate a report. Sales happened in India as well as sales happened in US. From both the servers or from both the tables, we need to bring the data for generating a report, maybe daily report or weekly report or monthly report, or maybe quarterly or yearly, any kind of report. So we need to bring the consolidated data from both the servers. So now to bring, suppose we are generating the report from India. So we have the Indian sales data in our local database. We should also require the US sales business data which is present in the US database server. Now we need to access the data which is present in the US database server, which becomes remote to us. Now we need to bring the data from the remote server into local database. For this purpose, we require a database link. Definitely, without a database link, we cannot connect to the remote database server. And even though we are using database link, the remote database server should be up and running to access the data into our local database. So database link is the only communication channel or communication path which can establish a link between local database and a remote database. So using database link we can access the data. If it is yearly report or quarterly report or monthly report, we will be running the query only once in a month if it is monthly report, once in a year if it is yearly report. If it is daily report, every day we need to run the query. Or we need to have the data every time. We need the real-time data always. Suppose I wanted to see the sales happened at this point of time at 12 p.m. today. Now I need to have the data of local database as well as remote database. So I need to run the query via the database link to access the data from the remote server. Now when we are accessing frequently, maybe every 5 minutes or every half an hour, every 1 hour, when we are frequently accessing the data from the remote database server, since the data has to be traveled through the network traffic becomes heavy. Due to heavy network traffic, the performance goes down because the response time will be very less. So when we run the query, it's a plain select statement, select star from table. But the table is present in the remote server. So we use @database link. So via the database link, we are accessing the data from the remote database server. The data has to be traveled through the network, through internet or network, dedicated network, whatever. Now, when the data is transferring through the network, if the data volume is very high, it will take very long time to transfer the data from remote system to our local system, or remote database to local database. So to complete this process, it may take half an hour or 1 hour, sometimes it may be 3 to 4 hours. To avoid this, we go for materialized views. For the remote database objects, we create materialized view in our local database. Means the main purpose of materialized view is to reduce the network traffic, especially during the business hours. During the business hours or working hours, when we are doing the transferring of data through the network, the entire network goes down. The server will be busy. It cannot take further request for further processing. The server will be busy in transferring the data from one server to another server. It may not perform other services. So not only our process, the entire business process will become worst. The performance of the entire business services become worst because of this process. To avoid this, we are going for materialized view. The main advantage of materialized view is materialized view can store data in it, and it can refresh the data automatically based on the refresh option and refresh time interval or frequency what we have specified. Automatically it will do a refresh from the base table to the materialized view. Base table is nothing but the table which is present in the remote database server. So it will do a refresh, means a copy of the fresh copy of the data from the remote database table, and it will bring that data and store it in our materialized view. This refresh we can perform during the non-working hours or non-business hours or maybe non-peak hours. We know that the business may be peak in the evening time. So afternoon time, maybe in the morning time, the business will be not that much peak. It will be normal. During that time, we can perform a refresh, or during the non-working hours, we can go for a refresh, so that the data will be loaded from the remote database server and it will store in the local database server, from where we will be generating the reports or we will be processing the data operations. So since materialized view can store the data, we will have the data up to the last refresh. From the last refresh till now, the data may not be present, but till the last refresh, data is present. With that, we can continue the business or we can continue the process. Maybe the difference is the data is lacking in our report from the last refresh. Maybe if it is hourly refresh, from the last 1 hour, we don't have any data. But till, if it is 12 p.m. now, till if it is hourly refresh, up to 11 a.m. we have the data. 11 a.m. to 12 p.m. we don't have data. It's fine. So we may not have the real-time data always, but there will be a lag time. That lag time is the frequency what we set for the refresh option. If the frequency is hourly, 1 hour data, a maximum of 1 hour data will not be present in our materialized view. This is the main advantage of having the materialized view. And whenever we require the data from the base table, we need not query the base table's data through the database link. We can query the materialized view and we can get the data. And as we already know, the materialized view will not have the real-time data. It will have the data up to the last refresh. From the last refresh, we may not have the data, but that is fine. Up to 11 o'clock, we can build the actual results. Actual calculations we can do up to 11 o'clock. And because we are accessing the data from the local database, we are minimizing, avoiding the network traffic. We are not transferring the data every time from the base table, that is from the table of remote database to the local database through the database link. Since we are avoiding the network transfer of data through the network, the performance will be very fast. Not only the performance of our report generation, the performance of the entire business, the other processes also will be processing faster. That will be the main advantage of using materialized view. And another advantage is the refresh option. The refresh will happen automatically based on the frequency what we set. The manual effort is not required for refresh. The moment we specify the frequency as hour, every hour the refresh will happen automatically. So we need not bother. There is no manual effort for the maintenance of data in the materialized view. The refreshes will happen automatically, so that we can take rest. We need not worry about that. So once it is tested properly and the refresh is happening, automatically it will be continuing. The refresh happens automatically. So this is another major advantage of materialized view in terms of maintenance of data. The data will be loading from the base tables into the materialized view based on the refreshes automatically. So manual effort is not present here. So this is another advantage of materialized view. Now let us see some more points about the materialized view and refresh. Since we have the refresh as an advantage, what are the refresh options available in the materialized view and what are the other options available while creating the materialized view? Before going to our practical session, we will see what are the privileges required to create a materialized view. We require minimum of 2 privileges. One is create materialized view privilege, and since we will be using a database link, create database link privilege is also required. Create materialized view and create database link. These are the 2 minimum mandatory privileges required to work with materialized views, because we are always dealing with remote databases. To access the data from the remote database, we require a database link. So to create a database link, we require create a database link privilege, and to create a materialized view, we require create materialized view privilege. Then only we can continue working with materialized views. So the privileges required are minimum 2. One is create materialized view. This is one privilege. Another privilege is create database link. If it is public database link, we require create public database link or create database link. Some create database link privilege is required, either private or public, and then create materialized view. These are the 2 privileges required. So these are the 2 mandatory privileges required to work with materialized views. Now let us see the syntax of materialized view. Before that, let us set our environment. We are setting feedback as 1, line size as 120, page size 500, num width as 5. That means width of the number column as 5, that is 5-digit numbers can only be displayed. If it is more than 5 digits, it cannot be displayed. We need to increase the num width at that point of time. Page size is 500, that is per page 500 records will be displayed. Line size is 120, this is horizontal length. In each line 120 characters can only fit with our setting. Feedback is 1, that means even if the select statement is displaying one record, the feedback will be on now. Means one row selected will be displayed. The default feedback will be 6. Minimum 6. Means if the select statement is giving minimum 6 rows, then only the below output 6 rows selected will be displayed. That is called as feedback. If it is giving 5, 4, 3, 2, 1, then the feedback will not be there. So we are making the feedback as 1, so that even if it is giving one record, it should display one row selected like that. So this is what is the setting we have done. Let us drop this materialized view if at all it is present. It is not there. So we are good. We can start creating materialized views. Now let us see the types of materialized views. So there are two types of materialized views, normal and pre-built. Normal materialized view and pre-built materialized view. Let us see the syntax of normal materialized view first. Create materialized view, view name. This is the name of the materialized view. Next, build clause. Build immediate, build deferred. We can choose any option, either build immediate or build deferred, or build clause is optional. We can ignore that. When build clause is not there, it is immediate. What is immediate, what is deferred, we see later. The default build clause is immediate, or we can also use deferred. Next, the refresh option. We have 3 refresh options: fast, complete and force. Fast refresh, complete refresh and force refresh. These are the 3 refresh options we have. Next, the refresh event. So we have 2 triggering events for the refresh, that is specified in the on clause: on commit or on demand. When we say on commit, whenever we perform a commit, automatically a refresh will happen. Or on demand. On demand means it is a manual effort. Whenever we demand for a refresh, then the refresh will happen. This is manual effort. Commit is, this is whenever we do a commit, automatically the refresh will happen. What type of refresh will happen will be specified in this refresh option. So whenever there is a commit, what type of refresh it will go, that defines in this clause: fast, complete or force. If it is fast refresh, whenever there is a commit, so it will go for a fast refresh, or it will go for complete refresh, or it forces to decide which type of refresh it is. And then there is one more optional. This on commit, on demand is also optional. It need not be specified. We can also specify a time interval over there. Instead of specifying on commit or on demand, we can specify our own time interval. Maybe hour, daily, weekly, every 30 minutes, every 3 minutes. We can choose our own time frequency here, or time interval. Next, query rewrite, enable or disable. By default, query rewrite is disabled. If we want, we can enable the query rewrite. So what is query rewrite, we see later. And then the select statement. See, in case of normal view, create view, view name as select statement. We do not have any other options. Here also, create materialized view, view name as select statement with other options. So here we specify a select statement. Based on the output of the select statement, the materialized view will be created. So we need to specify a select statement. It should give some result. Based on the output or result of the select statement, materialized view will be created. Another type of materialized view, which is pre-built. Create materialized view, view name on pre-built. See, there is no build clause, but we specify on pre-built table clause. This indicates that this is pre-built materialized view. There are some restrictions. Those restrictions we discuss later. And then refresh. Any one option in this, fast, complete or force. And then on the triggering event, commit or demand, enable or disable query rewrite, and then select statement. The only difference between normal view and pre-built materialized view is normal materialized view and pre-built materialized view is here in normal materialized view build clause will come, in pre-built materialized view the pre-built clause will come. Except this, rest all are same in both the types of materialized views. So as of now we park these options aside. So we use refresh option, means the type of refresh. On also we park it aside. Query rewrite also we park it aside. Instead of on triggering event, we go for regular time interval as frequency for refresh. So we specify the time interval for refresh, and then type of refresh, create, select. So query rewrite option we are not using, build option we are not using. So at the end we will discuss on these options later. Now let us create a materialized view. Create materialized view. View name mv_emp is the materialized view name. Refresh complete. We are going for complete refresh. What is complete, what is fast, and what is force we discuss later. Start with sysdate. So here we are specifying our own time interval. Start with sysdate. This is the first refresh. When we wanted to start the first refresh, and then the subsequent refreshes, the frequency of the refreshes. Next is trunc of sysdate plus 1. Trunc of sysdate gives the midnight 12 o'clock of today. Plus 1 means 1 day. So every day, this is daily refresh, but the refresh will take place midnight 12 AM. So this is night time, this is non-business hours, non-working hours. During that time we are going for complete refresh. And the statement is select star from EMP where department number equal to 10. From EMP table, whichever the data is there in department number 10, for those data we are creating a materialized view here. Means every day there will be a refresh at night 12 AM. Every day whatever the data is there in base table in department number 10, all that data will be refreshing here. This is because of complete refresh. We got insufficient privileges. We do not have privilege to create materialized view. Insufficient privileges. So we require a privilege. So connect to sysdba. And then grant create materialized view to the Scott schema. Grant succeeded. Once grant succeeded, then connect back to the Scott schema and then execute the same statement. Refresh complete. Start with sysdate plus 13 by 24. Next is sysdate plus 5 by 1440. Let us analyze this. Complete refresh we discuss later. Start with sysdate plus 13 by 24. Let us execute that. Select sysdate, comma, sysdate plus 13 by 24 from dual. See, for this sysdate, we are adding 13 by 24. That means 13 hours. 1 by 24 is 1 hour, into 13 is 13 hours. We are adding 13 hours to that. So when we convert this to 2char, then we can see the actual. Two char of sysdate plus 13 by 24, comma, we wanted dd mon yy yy hh mi ss and then am or pm from dual. See, this sysdate plus 13 by 24 became 13 December 2016 1:38:08 am, because now it is 12:38:08 pm. We are adding 13 hours for that, so that it became 1:38:08 am. Since we are creating the materialized view now, it will do a refresh at present. While creating the materialized view, it will go for a refresh. After that, the next refresh will happen at 13 means today night 1:38 am, and then every day night at 1:38:08 am the refresh will happen. So we are creating on DEPT1 table. Let us create DEPT1. Create table DEPT1 as select star from DEPT. We are making a copy of the existing table DEPT as DEPT1. But when we copy the table, the constraints will not be copied. So DEPT table has primary key, which is department number. But the primary key constraint will not be copied when we create a table using CTAS, create a table as. So now DEPT1 will not have primary key. To create a materialized view, the base table must have a primary key on that. Then only we can create a materialized view for that table. Base table is nothing but the table on which we are creating a materialized view is called base table. Now we are creating the materialized view based on DEPT1. So DEPT1 becomes base table for the materialized view MV_EMP. DEPT1 table does not contain a primary key constraint. This is the restriction. So to create a primary key